Right, so one way or the other, the first DNA started on Earth. We have life, and life, of course, at the beginning was like in terms of microbes. Now we think of microbes as basic, really, forms of life, but they're really amazing. They are these packs of life which have DNA inside of them, and they can do some pretty amazing things. Not to mention the fact that they can pretty much survive anywhere, and they're very clever. Not that they have big brains at all, but they just the way DNA works. It can survive in many conditions. All life on Earth, you see 3.6 billion years ago, this is where we estimate life started, about 1 billion years after Earth formed. So about 1,000 million years there was no life, and then somehow life started, and it was all microbes, all these tiny organisms around. And this was, we all have a common ancestor. This is something I'm saying. We all have a common ancestor. So if you go back to your grandfather and the grandfather of the grandfather of the grandfather of you, go back enough billions of years, you have a common ancestor with bananas, with strawberries, and with germs. So, which is kind of weird to think about, but it's true. It's a true fact. In fact, not just that, but this is one of the weird things. You and me, we have 10 microbes in our bodies for every cell of us. In other words, 90% of the DNA inside you is not yours. 90% of the DNA in your body belongs to some other creature that sees you as some sort of a bustling city, a metropolitan of germs, which somehow manifests itself into a creature that survives for a while. But we are not as much us as we want to think. We are not necessarily a single entity, which raises a lot of very interesting discussions. This is the family tree. So you see grandma there. This is, humans are kind of here. You got the, I can't expect you to read all this, don't worry. But if you look back, essentially it's if you want to consider the life, so it all started here. And this was about 3.6 billion years ago. And it was all essentially bacteria of sort. Then, about, say 1 billion years ago, you had the archaea, a few other kind of plants then came, the fungi, and all these other creatures kind of evolved later in the process. And then you have the sharks, and then you have the fish, and you have all these other reptiles and birds and mammals. We all have a common ancestor, which is really, really interesting to think. Don't worry too much about this graph. It's a bit complicated for this presentation, but it's an interesting idea to know that we share a common, we're all part of a big family. The Earth family, which is quite interesting. There were many interesting things throughout our family history. For example, 2.5 billion years ago, there were germs, or these microbes, which started making oxygen. And we cannot survive without oxygen, but for other microbes, oxygen was poison. And so the whole process of generating oxygen turned out to be deadly. It was called the Great Oxygenation Event. There was so much oxygen released to the atmosphere that at some point it got to this critical mass and all the creatures started dying off. We passed that, we then went into Snowball Earth, where almost all of Earth was covered in snow or ice, was frozen. And then it defrosted, and then it got frozen again, and then it got defrosted. All these things happened throughout history. We have evidence for that. But evolution, you see, is a powerful force. Life itself does not give away so easily. Survived all that. 500 million years ago or so, the Cambrian explosion. Suddenly, we don't even know exactly why, all these wonderful creatures started showing up on Earth. The trilobite, and on land, and all these weird shells, and kind of crab-like thingies, and other weird thingies. All sorts of animals which were relatively quite complicated and advanced compared to what was happening beforehand. The world was very different. All the continents were connected in this mass continent called Pangea. There were land creatures, which were proto-dinosaur creatures. There were creatures living under the ocean, trilobites, as I mentioned, the ammonites, and all sorts of other creatures, lots of sea plants and so on. But then they all died. Almost all of them. 95 to 97% of the species became extinct in a very short period of time, which was called a mass extinction. this mass extinction was the biggest mass extinction we know of until today, and it was pretty devastating. It was a combination of volcanoes and germs which were created as a result, and lots of other things we kind of still trying to figure out exactly what happened. It was a very nasty time to be on Earth. But life, you see, is a powerful force. Evolution did not give way. The life that survived this catastrophe survived and went through and evolved further to adapt to life. And then we get to the age of the dinosaurs. We all love dinosaurs. They're awesome, these ginormous lizards. This was their home for about 150 million years. In fact, they've been around on Earth almost twice as much as since they've been extinct, which is kind of weird. There were lots of dinosaurs, and there were, all sorts of variety. They covered the land. But you see, their brains were not very evolved. And one of the things that they did not have is a space program. And if they had a space program, maybe they could have prevented this catastrophe, which happened one very bad day about 65 million years ago. Started off as a normal day until this ginormous rock from space was caught in the gravity of Earth. Unfortunately, bad things happen sometimes. And as a result, all these wonderful creatures, or at least most of these wonderful creatures, became extinct. This is the Bay of Mexico, essentially. The crater was so large, it's now part of the ocean. This catastrophic impact of the meteor was far greater than thousands of nuclear bombs all exploding at once. Earth was not only this massive wave of debris, there were massive tsunamis, there were fires everywhere. Earth was covered in a layer of dust that prevented from light to come in, and if you didn't die from the impact or the aftermath, you just died of starvation because there was nothing to eat. Many creatures died. Very bad, tens of thousands of years which existed on Earth afterwards. So this mass extinction was another one out of 5 natural mass extinctions we have until today. We, not you and me, but humanity has now been creating the 6th. We are officially in the 6th mass extinction in the known history, because we are killing animals, we are making them extinct in a faster rate than the dinosaur extinction. We are killing them off! Poor little things. But you want to have schools and roads and no forests and no bears around. It is what it is. Okay, so evolution, remember, it's a powerful force. Did not give in. From the ashes rose the mammals. So this accident, this cosmic accident of a meteor hitting Earth completely shifted the direction of evolution. And suddenly, these tiny creatures which were hiding in the shadow of the colossal dinosaurs were spreading all over the Earth. These were like rat-like creatures, which is not the best way to talk about your parents, but hey. It is what it is. They evolved with time. All of Earth was covered with forests. This was about 15 million years ago, the ancestor of all apes. Now, we don't know whether they actually look like this. It's kind of, we think, maybe. This was about 15 million years ago. And then, if you look at the tree of apes and monkeys, we did not come from monkeys. Monkeys are one branch of the tree, and then you have the New World monkeys, the American monkeys, which were a different type of branch in the tree, and then you have the apes, and the great apes, which are the orangutans, the gorillas, the chimps, and humans somewhere there. So this is essentially the one way to look at the family tree. If you go back, maybe 50 million years, if you want to be a bit more specific, you can look at this little family tree, which includes our good friends Lucy, the Australopithecus, which was found in Ethiopia in 1974 and was named after the beautiful song Lucy in the Skies of Diamond. The Homo habilis, the Homo erectus. What we see is a progression of bigger and bigger brains, less and less hairy people, although there's always some exceptions if you go to the pool on the wrong day. We have some side branches like the Homo neanderthals, which were these wonderful, almost human-like creatures, which were amazing. They made art. They have cave art from Neanderthals. They made instruments, they lived in societies. We think they had language. They used to live in really advanced communities, all died out. Probably because of us. I mean, we kill each other all the time. Killing other species was probably a very common thing to do. The Homo erectus, they lived around until only like 100 years, 1,000 years ago. The Neanderthals lived only until about 20,000 years ago. Now, this is kind of the classic book, you know, the science book vision of it. There are refinements happening all the time. I'll give you an example. So because of DNA gives us so much more information that we can learn from bones. For example, we find out that 2.5% of your DNA, on average 2.5%, comes from the Neanderthals. So there must have been some love stories there happening between the Neanderthals and the humans. So 2.5% on average of all humans have some Neanderthal DNA. What is even more interesting, just a few years ago, 2010, in Siberia, there was this place called the Denisova Cave. And the researchers went in there, and they've done a lot of digging, looking for some remains of human-like creatures, and they found this tiny pinky toe, fraction of a pinky toe, and a tooth. They extracted the DNA from that. And they found that it belonged to a new type of creature, which we now call the Denisovans. We don't know how they look like, or what they used to do, or where they used to live, but we do know this. The Maoris, the Aboriginal people, the Islanders, the Tibetan people have about 3 to 5% of their DNA coming from the Denisovan people, which is quite interesting. In fact, you know, if you've ever seen the Sherpas of, you know, Nepal, the people who go up these insane heights, they can, you know, they breathe there without anything, while all the Europeans are really struggling with gas masks. We can survive there. They can. They have a mutation in the part of the DNA that came from the Denisovans that allows them to survive in this high altitude, which is really interesting. There is one more ancestor which we see the traces of the DNA in. Unfortunately, we don't know anything about them yet. So there is one more species of human-like creatures which somehow got mixed in us, and we don't know anything about them. It's just wonderful to think that there's so much more to discover in this wonderful world. This is us, our ancestors. They were as smart as us. They look a bit clueless. They didn't have, you know, a supermarket or Kohl's to go buy razors. But hey, you grow one of these guys in your family, they would play Xbox and ride skateboards and do everything else that everybody else does. Our secret, of course, is our brain. This is what makes us so special. This is what makes you so unique. We are animals, but we are animals with an added value. And that is that big, powerful brain of ours that allowed us to conquer the world. We live everywhere, we humans. Anywhere from Alaska to the tundras, to the deserts, to the islands, to the forests and the rivers and the islands. We have gotten to almost every corner of this planet. We took over the planet. We started in Africa, we went to Europe, we went to Australia. In fact, we actually got to Australia in some ways before even Europe, because there was this wave of migration. We crossed the Siberian tundras to Alaska when it was part of the Ice Age. And so people got to Americas about 20,000 years ago, 15,000 years ago. And then about 7,000 years it took them to get all the way down to Argentina. This is the human stories. It's one of those things, you know, Africa is where it all started. We are all black and proud, you can say. Black people generally have 4 times more diversity in their DNA compared to anyone else, because they've been there in Africa for so much longer. Remember that people started about 200,000 years ago. So most of the human history, we have been in Africa, which is quite interesting. I like to say that humans are a bug in evolution. We are, you know, we just showed up. If you look at the bigger scheme of things, from, you know, the start of life until now, we just, you know, just literally showed up. And we stole the stage from everyone else. We are a bug in evolution, and it's all thanks to our big brain. So where do we go from here? What are we going to do next? What is the next step that we are going to take in our conquest for this universe of ours?